Creative Commons copyright allows reproduction, but authors must be mentioned. I suggested waiting for hunger arousal before any meal, as you know. There is much more to remember about the role of energy availability on body functions. Energy availability causes unwanted feedback reflexes. An important example is intestinal absorption. This is the final result of digestive and propulsive functions. I measured intestinal xylose absorption in 28 pairs of female rats, half kept at 6C, half al 30C. On ordinate, absorption in warm environment in % of absorption in cold environment. Xylose was measured by detracting the amount remained in intestine from the administered amount. On abscissa, the time spent in the assigned environment before the test. The difference between environments is already significant after 4 hours, becomes maximal after 10 hours. Then, the difference decreases, for a recovery of absorption. I measured intestinal absorption in adults by urinary xylose absorption test. I maintained for 4 hours 15 adults in a cold environment, 18C, and repeated the tests in 10 adults at 28C and in 5 adults at 33C. Ordinate report xylose absorption in warm environment, as percentage of absorption in cold environment. You see a significant absorption decrease at 28C that becomes larger, about 40%, at 33C. It is well known that energy expenditure decreases in a warm environment. Maintaining same intake, energy availability increases. A greater energy availability decreases absorption. The increased availability is associated with an intestinal absorption decrease. Intestinal copious nutrients promote bacterial growth. 140 duodenal mucosa biopsies were divided in 2 groups, half consumed at dinner, and half without dinner. Bacteria were counted, CFUs, and resulted to be higher after dinner, 40 times on celiac mucosa, and 11 times on normal mucosa, p 0.001. Energy availability is important and requires an assessment. An index of energy availability may be blood glucose, Bg, for 3 considerations. Bg is correlated to other nutrients. Bg outflows earlier, and 3. More completely from blood than other nutrients. Fasting Bg is poorly reliable, but preprandial Bg has 3.8 mg/dl variability in the same subjects. Confidence interval. Mean blood glucose, MBG, is calculated from 21 preprandial measurements, reported in weekly diary. MBG is quite consistent. After 5 months, MBG shows a confidence interval of 5.0. Mean blood glucose, MBG in the single is associated with energy intake, with resting metabolic rate, RMR, with energy balance, and with insulin resistance. Instead, MBG is stratified in the population, and explains health differences by its association with insulin resistance, fattening, and diabetes. Reliability increases from fasting Bg, preprandial Bg, to mbg. Fasting Bg's level largely depends on the start time of post-absorptive period and dinner energy intake. Recognition of low Bg, initial hunger, causes a decrease in mbg, and in RMR. mbg decreases from 91.3 to 76.9 mg/dl in 70 infants. RMR decreases from 58.6 to 49.0 kcal/kg/d, that corresponds to a -15.4% in 14 toddlers. Empty columns represent resting metabolic rates, RMR, by indirect calorimetry, in 14 2-years-old infants. Black segments show the RMR decreases in each subject, after 50 days of training initial hunger meal pattern, IHMP. Mean RMR decreased significantly in the entire group. There is a direct proportion between RMR at recruitment, empty columns, and RMR decrease during IHMP, black columns. We studied mean Bg, mbg, of 89 adults at recruitment, and individual decreases after 5 months training initial hunger meal pattern. On abscissa, recruitment mbg, and on ordinate, columns show the mbg decrease for each single subject after 5 months training. Red columns mean significant decrease. mbg, like RMR, decreases during IHMP, in proportion to the height value at recruitment. The subject who had 100 mg/dl mbg at recruitment, decreased about 30 mg/dl under IHMP. This implies that RMR and mbg are correlated. On the left, a third of subjects, low mbg group, that is already correct and insulin sensitive by free choice at recruitment. This group shows an mbg of 76.63.7 mg/dl both before and after training. On the right, there are 62% subjects that have high mbg, and decrease mbg and body weight under IHMP. This group improves their meal pattern and acquire insulin sensitivity. In the previous slide, the subjects on the left do not change blood glucose, mbg, after training, but maintain the free choice meal pattern, that is associated with insulin sensitivity already at recruitment. This spontaneous meal pattern may be the reference meal pattern for all. Initial hunger, IH, and insulin sensitivity coincide right to 76.63.7 mg/dl. This is the Bg of initial hunger in a portion of subjects of 4 separate studies on mean weekly Bg, mean Bg. The arousal of IH 3 times per day, and of the associated blood glucose lowering mark the initial hunger meal pattern, a subjective energy intake restriction, that is reproducible. We studied mean BGS at recruitment in 28 students, 18 years old. MBG was 75.57.4 mg/dl in 19, the majority. In 8 subjects MBG was 85.69.9 mg/dl, and 95.619.8 mg/dl in 1. In a separate investigation, we found higher Bg levels during preprandial hunger after intense physical exercise. The 8 youngsters with an MBG of 85.69.9 mg/dl might have high MBG for intense physical exercise, not checked. Notice that over 60 years old, the training failed 9 times out of 10. Moreover, we measured total daily expenditure, TEE, in 10 toddlers, by doubly labeled water at recruitment, and after 50 days of training initial hunger meal pattern, IHMP. The significant decrease of daily energy intake was 18.0%, and the significant decrease of total daily expenditure was 15.5%. There was no significant difference between intake and expenditure at recruitment, and at final assessment, and in the decreases. These findings validate energy intake reported by diary. Even more important, these decreases reject the null hypothesis between demanded and scheduled, conditioned, meals. The 10 toddlers acquired low MBG in association with insulin sensitivity, thanks to practicing IHMP. Thus the 15.5% pre/post difference is also the difference in TEE between insulin resistance, conditioned meals, and insulin sensitivity, demanded meals. Heat loss is higher during resistance for presumable increase of ineffective Krebs cycle. A higher heat dispersion is an obvious consequence. Every morning, 50 autoanalyzers measure the same unknown glucose solution in Tuscany. Differences in measurements are contained within 1 mg/dl. At patient's reception in hospital, blood was kept and 1 milliliter was divided in 2 parts, a heparinized blood sample for the autoanalyzer, and another for the patient's measurement with her/his glucometer. Autoanalyzer and patient's glucometer measured around 89.0 mg/dl in 85 comparisons. The mean difference, 0.97.1, was not significant. No bias. On absolute values, the difference was 5.74.3 mg/dl. On ordinate, the subject's number out of 120 recruited adults, in each stratum. On abscissa, mean blood glucose, MBG, stratified in 10 strata, columns. Each stratum, column, contains people that are similar in MBG, and differ in MBG from other strata. You see here a shed cell from intestinal, duodenal, epithelium. The cell is covered by thousands bacteria of few, 1 to 8, prevalent species. In 140 biopsies, duodenum showed bacteria in inverse, negative, relation to the time from last meal. In small intestinal mucosa, there are half immune cells of the body. The above portion in this figure shows an intestinal mucosa in a germ-free animal, and the below portion reports a conventional animal. The immune cell infiltration, immune response, is about 5 to 7 times as high in conventional animals as in germ-free animals. Half immune cells of the body are in the small intestine. Meal absorption is in competition with bacterial growth. Overgrowth of bacteria in small intestine is associated with an increase in the number of bacterial species. Immunogenic species increase from 5% to 15%, as we may think from the increase in IgG response. From 30 to 100 bacterial species promote inflammation in each alimentary canal. Nutrient excess increases the number of immunogenic bacteria. Monocytes, LDL, etc. become full of bacterial antigens, leave toll-Rogan intestinal mucosa, migrate throughout the body, and settle down in inflamed tissues. Here, monocytes, LDL, etc. increase inflammation, worsen and prolong chronic functional disorders, bronchitis, diarrhea, abdominal pain, joint diseases, allergies, etc. Monocytes, LDL, etc. worsen and prolong also organic diseases, respiratory obstructive diseases, pneumonia, ulcers, any infection, and sustain never-ending immune processes that cause deteriorations, vascular risks, local proliferations as basis for malignancies. Recognition and maintenance of low preprandial blood glucose, corresponding to initial hunger, allows lower bacterial proliferation, and lower immune involvement, preventing risks. Training protocol. 1. Suspend meals for up to 48 hours. 2. Locate physical sensation of hunger. 3. Measure blood glucose concentration, BG. 4. Mentally associate the physical sensation with the BG concentration. 5. Begin with a meal of about 300 kilocalories. 6. Repeat 1 to 5, increasing the meal size in proportion to the desired interval. 7. Repeat the above procedure for 2 weeks. At each arousal of physical hunger, compare the aroused sensation and the measured BG with the initial ones. 2 months after 2 weeks training, 64 trained and 72 control adults attended the hospital lab before breakfast after an overnight fasting. All declared current presence or absence of hunger and estimated BG. Actual BG was measured by glucose autoanalyzer. On Ordinate, blood glucose estimation, and on Abscissa, blood glucose measurement by autoanalyzer. The circles represent hungry subjects. Red circles show 18 trained subjects, and black circles show 42 controls, all sensing hunger. The estimation error equals blood glucose difference between estimation and measurement is significantly smaller after training, i.e., normal people can learn initial hunger. A small group of controls show low blood glucose, 73 to 85 mg/dl, in association with low estimation error. Thus, some people recognize low blood glucose without any training. Decreases of mean preprandial blood glucose after training versus values at recruitment for each trained subject. Column heights show mean BG differences 5 months after recruitment in 7-day diaries from trained subjects. Significant increases in blue, significant decreases in red, and no significant changes in black. On the x-axis scale, mean blood glucose at recruitment is reported in sequentially increasing order, not in linear correlation with segment length. The dashed division indicates the most significant division between subjects who showed no mean blood glucose decrease after training, LBG group, N equals 34 subjects, and those who showed significant decrease of mean blood glucose, HBG group, N equals 55 subjects. This threshold blood glucose demarcation point is 81.8 mg/dl, 4.5 mol/L, at recruitment. The figure shows that a third of population maintains a low blood glucose. This level is associated with insulin sensitivity, preventions of diabetes, vascular risks, functional bowel disorders, etc. The majority, 2/3, is able to acquire insulin sensitivity like LBG subjects after IHMP training. This learning is apparently easy, considering that part of population establishes the correct meal pattern by free choices. Abbreviations: HBG, high blood glucose, LBG, low blood glucose, that corresponds to 76.63.7 mg/dl. Initial hunger meal pattern, IHMP, consists of two mental habits. 1. The learned skill to recognize sensations of initial hunger, corresponding to low estimation error of BG. 2. Stopping meal intake, to have initial hunger 3 times a day. Endurance: we contacted 17 out of 26 trained HBG overweight subjects, 9-15 years after end training protocol. 3 out of 17 subjects decreased 10 kg body weight after training, but increased again 20 kg, after 13 years. 14 out of 17 subjects maintained the IHMP and a mean weight decrease of 5 kg from pre-training value, after 10 years. We studied IHMP in 149 subjects, 104 trained and 45 controls, who completed the 5-month study on weight, and in 120 subjects, 89 trained and 31 controls, who completed the 5-month study on insulin sensitivity, by oral glucose tolerance tests. Multivariate analysis of variance showed that training, IHMP, and mean BG were the most significant predictors of final decreases in BMI and in body weight. Thus, we report here IHMP effects in 40 normal weight subjects, with high MBG, 81.8 mg/dl, in comparison with 15 controls. IHMP produced significant pre/post and longitudinal body weight and BMI decreases. 26 trained overweight subjects with high MBG, 81.8 mg/dl, show significant pre/post and longitudinal decreases in MBG after training in comparison with 13 controls, p 0.001. Insulin area under curve, in μ/L during oral glucose tolerance tests, decreased by a third in 55 high mean blood glucose, HMBG, subjects, after training, in comparison with 19 controls. The decrease was larger in 34 trained low mBg in comparison with 12 low mBg controls. Significant changes in 55 high Berg subjects during IHMP. 1. Decreases of energy intake, mBg, HbA1c and, during oral glucose tolerance tests, insulin area, AUC, insulin, and Bg peaks, insulin at 60 and 90 minutes. 2. Increases of insulin sensitivity index from a mean of 5.9 to 9.8 and of the index of beta cell function from a mean of 1.0 to 1.4, p 0.05 on the pre-post differences versus controls. This is one-day diary of a diabetic man, 60 years, BMI of 33, treated with metformin. He had low preprandial blood glucose. 48 hours fasting did not elicit any hunger. I suggested to eat not starchy vegetables, up to 1 kilogram per day, and fish, or chicken, up to 150 grams per day. The strategy consisted in administering a diet, rich in essential nutrients and poor in energy. After 20 days of such low intake, 350 kcal/d, hunger arouse once. In these occasions, he added small amounts of carbohydrates. Following the IHMP, body weight fell from 84.9 to 67.3 after 4 months. Another diabetic man, 53 years, 123.5 kilograms, BMI of 39. No treatment. He never reports hunger, neither after 48 hours meal suspension. He came by eating about 1,130 kilocalories per day, RMR of 1,290 kilocalories per day, a moderate intake. His prep-radial Bg was constantly high. After 1 year of not starchy vegetables, up to 1 kilogram per day, and up to 200 grams of chicken or fish, his mBg fell to a mean of 79,3 mg/dl before dinner, in 1 week. This value has to be decreased by 4 mg/dl. That was the difference from autoanalyzer in 5 measurements on the same blood sample. He had attained low mBg before dinner, and, on the phone, he was hungry. Body weight fell from 123.5 to 107.0 kilograms, less of 13.4%. Apparently, a body weight decrease of 14 to 20% allow regression from alimentary diabetes. Scheduled meals are considered to be equivalent to those demanded by infants and by adults, null hypothesis. At birth, mothers decide on opportunity, customs, etc. We investigated 143 2-year-old infants with chronic nonspecific diarrhea, in a randomized, controlled study to prove the null hypothesis between scheduled and demanded meals. Results: demanded meals were associated with significantly decreased preprandial Bg, from a mean of 86.9 mg/dl to a mean of 76.4 mg/dl, with a significantly lower energy intake and with a prompt recovery from diarrhea, whereas scheduled meals were associated with high blood glucose, high energy intake, and significantly longer persistence of diarrhea. These differences reject the null hypothesis between demanded and scheduled meals. To emphasize these findings, we mention the National Children's Study, New England Journal of Medicine, obesity, diabetes, asthma, autism, birth defects, dyslexia, attention deficit hyperactivity disorder, schizophrenia, have increased in children in the last half-century. A study on the causes was decided by the U.S. Senate in the years 90 and ended in failure in the year 2015. An important change in human life is the cause of current ill developments, and remained not demonstrated. We studied conditioned intake, in comparison with meals started by hunger arousal. Conditioned intake is often started from birth, is widespread to about 60% of child and adult populations, is associated with meal consumption before exhaustion of the energy available from previous meals, is associated with progressive body weight increase, and is associated with overall inflammation. The inflammation is often either subclinical, or overlooked because the inflammation is generalized, without hints to energy balance, as in asthma or in joint pain. Common relapsing diseases are multifactorial, and patients prefer to give more importance to stress or physical exhaustion than to energy balance and overall inflammation.